Okay. So let me start my virtual machine as well. Okay, so we'll start with the very sort of basic level and gradually get up to speed with the 5 different sections of this lab. So this lab is also posted on the course web page in case you want to have a soft copy and copy paste or follow along. Let me show you where very quickly. So we go to our F1tenth homepage. So right now, and by the way, this is maybe also another chance. Although you will find most of the lectures are already in place, I am updating some of these lectures as and when we cover them. So the ones which are the future lectures is just for your reference if you want to skip ahead and get a feel for what's coming. So yeah, so right now we are on lab handout 2. We'll talk about the file system, the Catkin build packages stuff, and end the session with understanding the talker and the listener. So let's just go back. Okay, so at the very beginning, when you were installing ROS, so this is just a useful tip to always have in your back pocket that at some point, whether on the car or on your machine, things will not work. Okay, I assure you of that. Maybe not in this early part of the course, but once you actually start working with more packages and having many workspaces as well. So the thing I want to begin with is to always make sure that you are aware of where ROS is on your machine and whether the correct versions of certain things are in place. So to do that, we always do this print environment, which is basically a Linux command, but I'm going to pipe the output of this to only fetch the ROS related environment paths, right? So I just say pipe grep ROS, and when I run this, we can confirm a few things which are pretty straightforward right now, but this is I still want to show you how you ensure nothing has broken or they're not conflicting Python versions and so on and so forth. So we've seen this is where ROS is installed. In my case, I've installed the kinetic. If you have melodic, I think the path is still the same except melodic. And then this is also something we covered in the lecture that by default, kinetic and melodic, the build target and the Python version is 2. So this is where, if you have changed your Python version following some of those slide and tutorials, this is an opportunity to check whether ROS knows about this as well. Another thing to validate is obviously the distribution, and we are not using any other Lisp, API packages in this case, or at least the distribution that I have. So also you can see here that there's something called ROS version, which is 1. And I think in the very beginning I said that there is already something out there called ROS2, and so that's not within the scope of the F110 class this year. In the future, we may migrate to version 2 of ROS, but here's where you can confirm that indeed you are using the version 1 of ROS. So this is just a quick to do. Let's get to the heart of sort of what we discussed. So the very first thing that we want to do is we want to create a Catkin workspace. Okay, so remember that Catkin workspace is the file system that ROS must use in order to automatically know where packages are located and how to compile and how to direct the CMake system to the build process. And to do this, we'll create our first workspace together. What you can do is you can create a directory. So I'm just going to say make directory. I use the argument -p to make sure that if I create subfolders in the directory, the parent is automatically created as well. So I'm going to create a directory in my home folder called Catkin_ws. And in many of the tutorials and in the lab handout, you'll always see us creating the same directory name. This is not a requirement, okay? So ROS doesn't read this name and or pay attention to it differently from other directory names. This is just a useful name. So what I want to create is Catkin workspace, and within the workspace, I'm also creating a folder called source. So this is on page 3 of the handout. And so once we do that, we've done nothing yet, which is ROS specific. We simply created a directory. What we want to do is now change into the directory we just created. So I'm going into the source folder. And now I want to actually run the command which will initialize this source folder to become a ROS workspace. And to do so, we will run the command catkin _init _workspace. After typing init, you'll just hit tab and it will autocomplete. So when we run this, what has happened is it has automatically created, if you just do a list right now, you will see that it has created this cmakelist.txt in the source folder, which wasn't present because we just created an empty source folder. So this is the bare minimum that ROS needs to know that catkin _ws is a ROS file system specific folder. Okay, so a good habit is, we are not done yet. A good habit is, right now the source, there is no package inside our Catkin source folder, right? Because it only has a CMake file. But this is where future packages such as beginner tutorial or other packages will reside inside the source subdirectory of your Catkin folder. And a good practice is always, whenever you do anything to the source or you add anything, and this is the first time we've initialized, so we have also, we don't have any interesting code to run yet, but what you should always do is when you touch any file within the Catkin workspace, it's a good habit to always build whatever you have in the workspace. Okay, so to do so, we can just change the directory to one level up and go to our original workspace folder. So now I am in just the Catkin workspace folder. And here I will run my first build command called catkin _make. And you can see, even though there was no source code in our empty workspace, there's a bunch of stuff which happened. And I'm hoping you're following along and you see the same sort of things which are echoed on your terminal session as well. So what just happened, right? What did it compile? There was nothing to compile to begin with. And so what has happened is Catkin make has invoked this Catkin build system. And now if you check the contents of the workspace, let me clear it so it's visible again. So now I'm in my Catkin workspace and I list the contents. You can see there's 2 additional folders. And I know maybe the blue on this terminal color is not visible, but you should be seeing it on your terminals as well. So it actually doesn't matter, right? So what you should see is we have 2 more folders, build and develop, as promised, because these folders are also necessary for the build system to know that this particular folder, Catkin workspace, is actually a ROS workspace. Are we done yet? Not quite. There's one more thing we have to tell our system. We have to tell the Ubuntu or the Linux that this folder is a ROS workspace as well. ROS knows about it, but our session doesn't know about it. So to do so, what you would typically do is you would say source and provide the path to the setup.bash file within your workspace. So the correct path is source, Catkin workspace, the folder, the subdirectory devel, and the file name is setup.bash. By running this command, I am informing this terminal session that if I now want to try and run any packages within my workspace, where to find them. Right now we have 0 packages. That's obvious. In fact, the thing is, every time you open a new terminal session, you will have to tell it where to look for Catkin workspaces. So it's like a pain, right? Because you don't want to do it every time. So we've done this before. We've seen this before in the slides as well. What you really want to do is you want to run the source command, but not for every session, but just echo this entire path to the bash rc file, which is invoked every time to the .bash rc file, which is also in your home directory, and this bash rc file is read every time you open a new session. So I'm still on page 3 in the handout if you're following along the stuff, right? So I'm just echoing this in my bash rc file, and to confirm that that it worked, I can show you what this has the desired effect. So if we look at our bash rc file, we've just added this last line as a permanent line to the file. So this makes sure that every time I open an instance of the bash shell, it knows where Catkin workspace is. And that will autocomplete or help Ross find future packages in the workspace. So any questions on how to create a workspace? The whole thing happens by itself when you just run 2 commands. One is catkin init space and the other is catkin make. Okay, so let's move on to the next thing. And the handout that you have is also like a tutorial, right? So if you are unable or confused at a future point, I've shown some screen outputs, and it also reads like a tutorial. But right now, I'm not going to go over the handout verbatim, so we'll just jump over to kind of I guess the commands that I want you to play with. Okay, so let's skip ahead to section C in the handout. So learning about the ROS file system tools. And in order to follow along the tutorial, we will actually, and let me change back to my home directory rather than my Catkin space, although it doesn't matter. So to follow along the tutorial, we'll first have to install a package, a new package that we will then use to interact with. And so the package you can install by just saying sudo apt get install, and then the package we want to install is called ROS Kinetic, and replace Kinetic with Melodic if that's what you are running. And the name of the package is ROS Tutorials, but I want you to just run ROS, and if you hit tab, it will show you options of many packages which are useful. And this is one direct way to install some of the packages that will be useful in the future, but right now we only want to install ROS Tutorials. Okay, so just fill in my password, and nothing got installed because I've already installed it previously, but for you it may look a little bit different. So why did we install this? Because we want to now use some of the commands that will utilize this package, and it will help us understand the ROS equivalent of some Linux commands to interact with the file system. So we did cover this in the lecture as well. So if the first command is C.1 in the handout. This is called Rosspack. And so the syntax of the command is, why would you use Rosspack? You want to find where a package is or whether you have a certain package installed. Okay, so you can literally say Rosspack find, and let's look at a very basic package called ROS C++. So although in the lab session, in the lectures and the lab sessions, we'll mostly use the ROS Python API library. We can still find any other package. In fact, I think I showed you the TurtleSim example during one of the lectures. So we can say Rosspack find ROS C++, and it'll just echo out where this package is located. So it's pretty straightforward. So can someone tell me where is TurtleSim located on your machine? Yeah, just yell it out. Yeah, so it's the same path, but instead of ROS C++, it's where the TurtleSim package is located. In fact, one of the things we saw is that TurtleSim is split into a different source directory as well. But that is correct. So if you simply run Rosspack TurtleSim, because that's sort of the only package that we are interacting with right now. Oh, Rosspack find, so I'm making an error. It's sort of the same path, but it has just a total sim package. So let's move on to the second question in the handout. So can someone check whether the total sim package depends upon something called gen node.js? So node.js, something to do with node.js. So you need to use Rosspack and some argument to Rosspack to confirm whether this statement is true or false. That total sim depends upon the gen node.js package. So figure it out, and then in a second I'm going to ask how many people think it is true versus false. Yeah. So maybe someone can help us out by telling us what Rosspack command is going to be used to figure this out. Yeah.
The Rosspack depends total sim?
Yep. So try that out. Rosspack depends total sim. So how did we know what to use? You can always say, Rosspack help. I will tell you all the sort of arguments which are allowed for Rosspack. So with this new information of which command to use, so how many people think the answer is true? So what about the rest? I want to hear from someone who thinks it is not true. Yeah.
So these are all things packages total sim needs to run, right?
Yeah.
Okay.
So yes?
Could you say the question again?
So if you look at your handout, underneath section C.1, the question is that does the package total sim depend upon this random package gen node.js? And I wanted to know if the statement is true or false. And about half of you think it is true, but I want to now hear from someone who thinks this is false and why. So does that mean everybody thinks this is true? So it's a pretty 50-50 question. So yeah, it is true, but there is a caveat, right? So the thing is, if I say Rosspack depends, and I only look at the first order dependencies. So what do I need for total sim to run? And I look at a command Rosspack depends 1, and then I say total sim, the name of the package. It actually doesn't need that package directly to run. So what is happening is the gen node.js is required for one of these packages to run. So it is true that total sim eventually depends upon this random package, and you probably ran the same command but without the option 1. And indeed somewhere, okay, right here we find the special package, but this is only because one of the original packages has a dependency on this package. So both answers would have been accepted. Okay, it is false, but it is true at the same time, I guess. So yeah. Say that again.
Why would you ever want to know about only the first order dependencies and not?
Okay, so the question is, why do you care only about this small subset of dependencies? I have faith in you that you can actually answer his question. So yeah.
Otherwise, those could be huge.
Exactly, right? So in your build dependencies and execution dependencies, you can have a field day of writing all the dependencies as much as possible, but use Catkin's information, right? So if you download a new package, you can just check the first order dependencies and make sure that your package XML file or the CMake file has that list covered. Everything else will be handled. Okay, so that's why you can check, and it becomes important when your package size is very, very large and it has many, many nodes. Okay, so this is still easy stuff, but I want to at least have one opportunity to cover all this. So the next sort of file system command is pretty straightforward. It's called rosscd or ross change directory. So just like we said rosspack find C++, now I can say change the directory to where C++ is, and we already know where this is located. So this is just confirming that indeed it directly navigates to ross C++. This command is so frequently used, it'll be your best friend, because when you have many packages in your workspace, you don't want to retain or remember where a package is located. So the way to do this is just change directory right into the package. And sometimes you don't want to change the directory, you can just simply list the contents of the package using ross list. And we saw the example, so I can say total sim, right? So this will tell me what are the contents of some package without changing my current working directory. Okay, just like a way to probe where things are. So I think in the handout there's a part where I say that where are the total sim images located on your machine. We saw this example, so this is just another opportunity to say rosscd total sim, and if you just type in images, how do I know there's a subfolder called images? Right here, because I use ross list to see the contents of this package. So now I want to say change my directory to this images subfolder, and so that happens right here. And indeed, this is where all the rendering of the turtle are stored. So if you have time to kill, you can design your own turtle and replace it with that image. Okay, extra credits for that in the homework. Okay, so this is just a quick overview of the commands rosspack, rosscd, and rossls. And these are the things that we will use to interact with packages. But we haven't built any packages yet. We've just initialized a workspace. So the next thing we will do is create a ROS package from scratch. And then we will add some files to that package. We will rebuild our Python nodes and make sure the talker and the listener are working. Okay? So let's jump ahead to section D of the session, and I'll clear this and always change to my home directory. All right, so we have a workspace on our machines, the Catkin_WS folder. Now we want to create our own custom package in this workspace. And so what we can do is we can change the directory into the workspace. So let's go to the source subfolder of the Catkin workspace. So this is I think D.1 in the handout, and all the stuff above that is for you to read, and just a refresher of what a workspace is, what package.xml is. So once we are in this folder, Catkin workspace source, if I list the contents, it's not empty, but it only has this default file which was created when we ran Catkin initialize workspace. Now I want to create a new package. And so you can run the command Catkin_create_pkg. So that's short for Catkin create package. Then you provide the name of the package you want to create. This will not autofill because you are naming it. So I just type in beginner_tutorials. And we saw that you can also provide a list of the dependencies of this package to other packages. So I want to use standard_messages. This is in section D.1. Make sure you don't misspell the dependencies because it will throw an error otherwise. Then it depends upon Rosspi because I want to use the Python API, and it also depends upon Ross C++, although we will not use that for the node writing. So my full command is Catkin create package, beginner tutorial, and 3 dependencies. And when you run this, no errors should creep up, and you can literally see that now it has created our package manifest file that we studied in the lecture. It has created the CMake list file for the Catkin build system, and in addition, it has created another source folder inside the beginner tutorial directory. Okay, not only did it create the beginner tutorials, which is the name of the package directory, it has created this subfolder as well. So now when we say ls, here is our beginner tutorial in the workspace. Okay, did everybody follow that? So the only thing we did was Catkin create package. So once we have this, what should we do next? What do you have to always do when you change stuff in the source? Exactly, right? So the thing is, don't run Catkin make while you are in the source subfolder. You always go to the root of the workspace, and I'm clearing it. So I'm now back in my Catkin workspace, and I can run, Catkin _ make, and it will take some time, but it should return no errors, and the build process should be completed. So still, we have created this package now, so Ross should know about where this package is. But just for completeness, you can even run again source Catkin _ workspace in the development, and you can source your setup.bash, because the contents of the setup.bash might have changed because of the build process. And we do this again to inform Ross where on our system is this package located. So let's go and inspect this package first before we actually start adding our own source code, right? So this beginner tutorials is a package because we use the Catkin create package file to just do this, but it doesn't have any Ross nodes yet, right? Because we haven't created any. So now, let me see if this works. So can I say Rosspack find beginner tutorials? Oh, it didn't find it. So let me initialize a new instance. Oh, I spelled it incorrectly. That's why. So there you go. We created a workspace within which we created a package called beginner tutorials. We haven't added any executables to this package yet. It's an empty package, not doing anything interesting. But because we have sourced the path to Catkin to begin with, any shell instance you launch will be able to find this. So you can run all of the stuff earlier, rosscd, rossls, on your new package. Okay? And so that's why always remember that your environment is sourced. Okay, this is one of the biggest reasons why things don't run. That's why I'm spending this additional 5 minutes on this single sort of topic. So while we are at it, let me actually change the directory to this beginner tutorials. So rosscd. So we are now in our newly created package, and let's check the contents out. So when we ran the command catkin create package and ran the build, it actually created a subfolder called source for us to drop some Ross nodes in. Right now, the source folder is empty. We can quickly check that. The source folder is empty right now. In addition, when you are back in your beginner tutorials, it created these two files, package.xml and CMake list. So let's check them out as well. So we can just open this file. You can use your favorite editor. I use gedit because it's just visible than Vim and others. So we can just say package.xml. So we didn't have to write this file, right? Ross and Catkin build system created this for us. And very quickly, let's just have a sanity check that this does have all the stuff we covered in the lecture. It automatically filled in the name, which is the same as the package name. This is just the version of the file. You can have a versioning system where, of course, the file improves. It picked up my username as the maintainer. It chose some default license. Actually, it did not. It says you have to fill in one. But here's the interesting part, right? So the build tool is Catkin, automatically filled. And look at the dependencies. These are exactly the 3 things that we specified when we said Catkin create package. So this is how this was automatically filled. But this is an instance or an example of creating a package from scratch. Another way to work with packages is to download an existing package and just use the existing source code. In those cases, it will help to check the Rosspack depend to make sure this file is up to date or doesn't conflict with what you have. Okay, so right now we don't need to edit anything in this file. Everything is built for us. We have execution dependencies and build time and runtime dependencies already specified. Let's also quickly check out the other critical file, which is the cmake list.txt. This is the cmake list file within the beginner tutorial directory. There's another cmake list which is at the source level. So they are 2 separate files. And as was shown in the lecture, this is a bit non-intuitive. We can make sense of some of the things. So this is pretty self-explanatory. It just requires a specific version of cmake, automatically fills in the project, automatically tells me what packages this project depends upon. And most of the other stuff is commented right now, but you will see very, very quickly as soon as next week, you will have to uncomment some of the files which tell where some custom messages are located. So I'm just trying to find that here. Yeah, so here you go. You see there's some commented sections of the CMake which says, do you have any custom messages that you would want to use when you are building this package? So right now we are using standard messages, so we don't care. But this is where we'll make some edits in the future. So we can close this file as well. And let's see where we are at in the handout. Yeah, we already saw the package XML, and we tried out our ROS CD stuff as well. Yes?
Can you explain why you have to keep doing the source, Catkin, Behl,
Correct. So for most of the ROS commands to figure out that where packages are located, it needs to have the path towards that package. And this is a property of these Linux terminal bash in particular. Sourcing just means that it needs to know what is the environment path. We saw the high-level path variables at the very beginning of this lab, which pertain to the path where ROS is installed. So any default things we can easily run by hitting autocomplete with tab. And so those things will not facilitate autocomplete, but in order for ROS to actually compile the code and be able of ROS versions of the file system commands to work, you need to tell the session, this is the directory where I search for when I type in a package name. Forcing the environment. And do this every time we build the workspace, just because there might be some part in this setup.bash which gets updated. Okay, I haven't shown you what is getting changed from one build to the other. And for the simple code, actually not much is changing, but I want to inculcate the practice. Always source your environment after you build it. However, to avoid running, if we didn't have the bashrc command edited in a bashrc file, what would happen is you would have to run the source for every new session. So the bashrc stuff is just to ensure that you don't have to do this for every new terminal session. Once you have sourced it, it's there, and for now you can launch the terminal. It'll know where the packages are. Every time you make a new workspace. Okay, so the bashrc file, very quickly I'll just show it so it's super clear. In my home directory, the path in the bash RC file has no information about beginner tutorial. Okay, it's just referring to the workspace setup.bash file, and you can check out what is the inside setup.bash file as well. It's sort of not needed really, but the answer to the question is when you compile the package, you source the dev this file again, and this particular edit to bash RC is more for convenience than for anything critical, because we don't want to keep sourcing every new terminal session. Okay, yeah. All right, so this was a good pause to take, because now we have accomplished two things. We have created a workspace and added an empty package to it. Empty not implying it has no files. Empty only means it is not doing anything. It has no ROS nodes. So let's fix that by adding two nodes to this package, which are the publisher and the subscriber nodes that we covered in the previous lecture. Okay, so now we get to the last part of the lab, which is in section E. So there are many ways of going about this. I'm going to show you the way the course has been set up, and the course has been set up such that we have a course Git repo. And for every lab or for every assignment or every tutorial, we continuously update the repo with new nodes, with new packages that you need for that tutorial. And so the way I'm going to show you how to populate your newly created beginner tutorials package is not the only way to do it, but it will be the preferred way, because it's the best way to fetch stuff from Git and make sure you have the latest nodes available in your local workspace to compile. Okay, so let's just look at that workflow and follow along. We are in section E. So what I would recommend is we first create simply like a GitHub directory in our home folder. So I can say just make dir. I want to call this GitHub, and then I can change into the newly created GitHub folder. And let me show you. The URL is included in the section E of the handout, but if it's not visible, let me just spell it out for you. So we want to go to https github.com/linklab-uva. This is the organization, and then the repository name is F1tenth-course labs. Right, so right now there's not too many files, but it should get you to this GitHub for this course, and you can simply clone this. So I can copy the URL, go back to my GitHub folder, and just clone this. So again, be careful of spelling out the path correctly, because you want to get the correct code. Okay, so I'm sure everybody knows how to use Git, so we won't, this is not a GitHub tutorial. So now we have this inside the GitHub folder. You can go into the name of the repository, which should be F1tenth-course.labs. And within that, for now, we only have a folder which is aptly called beginner tutorials. It's the exact same thing that you created. So did this work for everyone? I hope, right? Right. So now there's actually two ways to solve this. I should have not closed the URL. Let me quickly open it again to show you. So the way the course is organized is you can always expect the package folder as a subdirectory to this Git repo. Okay, right now we have a package called beginner tutorials, but in the future we may have more detailed packages. And so I want you to know what is a good practice to use a Git repo. So one way is to what is called symbolically link files together. So let me show you what that means. So what you could do is you can say whatever are the contents of the beginner tutorials, I want to just symbolically link them with my workspace. And symbolic link is different from copying stuff because when your source from which you are symbolically linking gets updated, when you do a git pull or a refresh, the contents of the linked folder will automatically get updated. So you don't have to manually copy paste stuff. Okay? So that is useful. But a simpler, more elaborate and deliberate way is to literally just say, I want to copy these files from this directory of the Git to this directory of my Catkin workspace. Okay, so for right now, we'll just use copy because it's more straightforward, and we don't have too many files that we worry about symbolically linking them. So what we should do next is, the purpose of this is, we have just downloaded some nodes which are in this beginner tutorial subdirectory in Git. So let's actually first check them out. We can say what is inside this new directory. So you can say there's a folder called scripts within beginner tutorials, and inside that are two nodes called listener and talker.python. Okay, is everybody still following along, or have I lost you? Okay, so this is my GitHub path. Don't confuse it with my workspace. This has nothing to do with the workspace. What I want is to copy these two files to the beginner tutorial and potentially the scripts folder inside beginner tutorial, which doesn't exist yet. And so what we can do is, this command is also shown on step 3 in section E in the handout. So just so that it doesn't, it's clear on the terminal, let me clear everything. So you can literally just say copy -a, which means I want to copy all the contents from the source, which is GitHub, the name of the repository, F1tenth course labs, the directory beginner tutorials, and I hit dot. Dot just means if there are any subdirectories, just copy those as well. So this is my source, and my destination is what? It's the Catkin workspace source beginner tutorials that we created, in the previous section of this handout, and that's it, right? So this is where I want to copy all the contents from my Git. So you can just run this. And if you didn't make any typing errors, we can specify by saying Ross list the contents of beginner tutorials. And sure enough, there is a new folder called scripts, which was just copied from your Git. Yes? Very good question. Because there are some default Git files which often will mess up the Catkin system, and this is just from experience, right? So if you want, you can play with the correct git ignore, but this is just more elaborate, but it's accomplishing the same stuff. So equivalent of doing that is, you can always clone the repository in whatever folder and symbolically link and not worry about manually copying anything. Okay? Yeah. Any other problems or concerns? Okay, so if you followed along, what we should have now is a beginner tutorial which actually does something useful. Okay, so, and notice again, I didn't have to cd to this to check the contents. This is where Ross ls also helps. So, get used to using these Ross commands. So now we've added some new code to our beginner tutorials. Surprise, surprise, what should we do next? We need to build our workspace again. Okay, we need to build these new nodes. But before we do that, sometimes when you add Python nodes in particular, you have to just make sure that they are executable. Okay, the Python file is actually executable. You have to give it the correct chmod privileges. In this case, I could have simply actually done Ross cd beginner tutorial scripts, and now I know these are the two files. and I could have just used chmod x one by one. They are already executable, but in some cases they might not be. So this is how you can just touch these two files while everything else is the same. Or you can use the command in the handout in step 3, where especially when you have a lot of packages, you can simply say, within the Catkin workspace. So I'm in my Catkin workspace. You can say find. This applies to all files such that the name of the file ends with .python. And when you do that, I want you to execute chmod x. So give it execution privileges. And then you can close off this command, and this will do the same thing. This is useful when you are not sure, you have just installed some new code from the repo, and you are not sure whether or not which directory contains Python files. In this simple example, we just know that 2 files were added. So I'm going to show you both just for completeness. Long story short, once you have made sure your files are executable, we can run catkin make in our root folder of the workspace. And it should, again, return without any errors. And just for practice, we should source this new workspace as well. So source Catkin workspace development setup.bash. And in doing so, what has happened is now we have added some executable nodes to our workspace successfully through this convoluted way of cloning the Git. So now it's time to use those nodes, and then that'll be the end of this lab. And let me now open a better tool when I have to launch more nodes. So if everything worked and you didn't receive any build errors, we can literally open a session and say Ross core. And now let's see whether Ross can find our new node. Okay, so I'm going to say Ross run, package name is beginner tutorials. It did find that. And then docker.python, it found the node as well. And if I run it, you can see this is the exact same thing we covered in the previous lecture. But now we are running our own custom node. Okay, is it running for everyone? Or if you have a problem, just let me know. So while this is running, let's also confirm what this node does, just as a refresher. So let's look at the source code. To look at that, I say Ross cd into beginner tutorial scripts, and just open the docker.python. And you can see this is exactly what we covered in our lecture. We import the API, and our Docker is a publisher. It's publishing on a topic called chatter. We can even validate whether this topic exists. Yes? What should be? Which one in the cat? There's now 2 beginner tutorials. One is in your Git repo, and the one is in your Catkin workspace. There should just be a folder called scripts. Yeah, and within that scripts folder are these 2 files. So when we did the copy, we literally just copied the folder to the Catkin package. Yeah. Okay, what you mean. So Git repo, you got me, right? So I lied as usual, I do. So the Git repo beginner tutorial directory is not a valid Catkin package yet because it doesn't have the package XML and CMake files. Okay, so we sort of skipped the step over there. And that is not true for future labs. When in future labs, we will release packages in the Git repo. They will come with their own package XML file and the dependencies as well. In this case, I wanted you to use the Catkin create package command. That's why we skipped that step. But that's a good observation. Yeah. And there's a question here. Yeah. You can put it in the source folder. Convention dictates that source folder is used for C++, and scripts is used for .python. Not that you cannot put these in the source. You could have done that. Okay, so we already spent a lot of time looking at this. What I want you to observe, because we'll do a little exercise in just a second, when I initialize this talker, I'm setting the anonymous argument to be false. Okay, so that means that literally the name of this node is just going to be talker, and it won't have that pseudo random thing. But if you go to the listener.python, so quickly let's just see that. So here, when we say Rosspack init, the anonymous flag is set to true. And since we already covered this in the lecture, this is the exact same code I went over. We are not going to go over this line by line. As you recall, the listener is subscribed to chatter. And since this is a subscriber, we are using spin. And if you go to the talker, it's going to use the is shutdown flag. We sort of covered this in the previous lecture. So let's launch the listener as well. There's nothing stopping us from doing that. So in this window, I'm going to say Ross run beginner tutorials and listener.python. And so the listener is receiving packages. Always a good way to visualize is just run rqt graph. Here's our very, very simple setup. Note, since we said anonymous to be true, listener has the name of the node appended by this unique identifier. So just to that, this is super clear. Let me open a new terminal instance and launch another listener. Okay, I'm going to say Ross run beginner tutorials listener.python again. And we have established another listener, which is subscribed to the same package. Okay, so this has to be refreshed. So now we have two listeners. And nothing broke. So before we break it, let's just quickly run through our usual stuff to make sure we still recall stuff from the previous lab session. We can quickly validate, okay, Ross node list. This is what we expect. Two listeners, one talker, one RQT graph. We can confirm the topic, Ross topic list. And we just have, the topic of interest to us is chatter. So everything is working, but now I'm going to try and launch the talker one more time. So can someone do it and tell me what happens before I show it on the screen? Try to launch another instance of the talker and then tell me what happens. Yeah. Anyone? Yeah, exactly, right? So if we try to launch another talker by saying Ross run beginner tutorials talker.py. Let me organize my screen a little bit better. So here on the left side is of my previous talker, and when I hit return on this new command, this node got a shutdown request and deregistered. And the reason is that a new node has registered with the same name. And the reason for that, as we saw, was because in our initialization of the talker, we have set the anonymous namespace argument to be false, that we don't want any unique identifier. And I said this at the very beginning in one of the lectures, that when you initialize a node, or in Ross, no two nodes can have the same name. And so there's easy ways to fix this. In fact, there's an easy way to name multiple instances of the node yourself. Okay, so instead of the random identifier, I can initialize the node with some arguments while I run the node. So I could have had named these listeners as listener 1 and listener 2, and this has to do more with namespace arguments and namespace handling in Ross, which we haven't covered in the lectures. But I just wanted to make sure you understand why we covered that point that no two nodes should have the same name. And so we've already seen this, but since we have a couple of minutes, you can always verify that indeed things are happening at the rate at which you publish. So let's look at what is the publication rate of chatter, and it should be around 10 hertz. It's actually lagging. Why is it lagging? Because there's other nodes running. So rate sleep is not able to maybe complete or maintain exactly 10 hertz. So the more nodes you have, the higher standard deviation you will observe. And like we've always discussed, there's no guarantees. You publish and there's no guarantees. You keep your fingers crossed that your message will be received by the subscriber, which is one of the shortcomings of ROS. So starting next week, we will cover 2 more advanced topics. One is what are launch. They will be your friends. So right now, I've already shared one way of launching many things without cluttering your desktop. But while using launch files, just launch multiple nodes from within the file. So you don't even have to run ROS code and then launch this and launch that. You write one simple script. It will take care of everything, and all of a sudden you are just interested in looking at the messages and the data being exchanged, looking at the RQT graph, working with that. Also, next week we will cover something called ROS parameters and ROS time. Time is very important in ROS. The way it handles time, there's a distinction between simulation time and real time, and we'll make sure everybody's on board. You can see in our talker and listener, there's this large 158041 number on the screen right now, which is ROS's interpretation of time. So I'm going to tell you where is this coming from, and it should be similar for your distribution basically. So that was it. This is our second lab session. I think we have covered enough for you to now attempt the first homework, which will release next week. The previous year's assignment has been removed from the web page, not because we don't want you to get a head start, only because we always change the assignment. So we don't want you to solve something which is not due, okay? So that's why I just removed it. But that's it. That is for the session today. So once again, we get to finish early, but subsequently our lab sessions will maybe even go 5 minutes beyond. So I'm buffering all this extra time that I'm letting you go. Okay, so hopefully follow this along, and if you weren't able to, if you had any trouble, just post it on Piazza, let the TAs know. And I will see you next week, where we will have our first interaction with what does it mean to be autonomous in ROS.